Hi, my name is Andrew McLaren. Today we're going to talk about naming chemicals, and we're really going to focus on these three main groups today. There are more naming conventions, like with like acids, they've got a particular rule set. They're kind of like an old thing in chemistry, so they've got weird naming rules. And then organic chemicals also have unique names because they were discovered a long time ago. But we don't really focus so much on the organic chemicals so much, like your carboxylic acids and your amines and that stuff. That is taught in some other countries at younger ages, but in the US, we don't see it until like the second half of college. General chemistry won't even include this. If you're in like most colleges, they might introduce this here, but they're not really going to assess it. The assessment really is going to be on these three main groups, and that should be at least 80% of the points for most high school classes. They really are focusing on these three. So that's what I'm going to do for this video, just to help you master that first, and then you can get the other stuff later. So when I'm tutoring students with this, I will give them an opportunity to give me a couple names and their chemical formulas and see if they can just say what those are called, like from the name, from the formula, or can you give me the formula from this name? And there's usually a couple things that come to mind. Most people are like, okay, I know how to say this guy, right? And that has some information in it, but they're only giving the information that's actually relevant for this thing. So if you were to look at NaCl, these are known charges. This is a plus one, this is a minus one. These are known charges. So it gets to assume that we know the charges, so you don't need to state it. And these are used to balance. So you can balance out the formula using those charges. So if I were to say what this is called, this just is called sodium chloride. So there's no prefixes needed. Because these are known charges, you don't need to state anything else. We know the first atom, we know the second atom, and we even know what number they are with each other because there only needs to be one plus one charge with one minus one charge to cancel each other out. This whole thing does not have a charge on it, so they should be canceling out. So if we can balance doing a little bit of algebra or canceling it out, and we know the charges, you don't need to say anything else other than the atoms. So that's one category. Then there's some other ones where like, okay, well, I do sometimes need to give some other information, and that's when you don't know the charges. So if we're talking about what's very similar to these ionic compounds, if we're talking about something with a transition metal, you might write that out as something like this. And there's a different version of this that looks kind of like that. These have two different names. So because iron is an unknown charge, you need to tell me the charge. So for any transition metals, you need to say what the charge is, and that's going to be a Roman numeral. So if we have iron with an oxygen here, I know that the oxygen should be like a -2 charge, and it looks like there's only one of them, so this is going to have to be a +2 charge. So this would be called iron II oxide. So the II is referring to the charge here. It is not the number of atoms, because if you were thinking it was the number of atoms, you might call this iron 2 oxide. It's really the charge. So we already know that the other thing is going to be negatively charged. A transition metal should be positively charged. It's just a matter of canceling or balancing those things out. So these are both ionic. So charges are relevant. Now, most students have a hard time kind of giving me some transition metals, but they can usually give me like a salt, like NaCl. And then I will oftentimes ask them to name these three compounds, just to kind of drive home the naming conventions. And usually they know these two from like biology. They know that this is called carbon dioxide. And you can see that now this 2 here is the number of atoms. But there's nothing out front. So there's no mono in the front here. So there's a di in the second, but there's no mono in front. Basically, the naming convention is that if there's a 1 here, you don't state 1. Or you don't state mono. So this again comes from old naming conventions. People were realizing things were combining with certain ratios with oxygen, the carbon. They kind of later came up with a more universal naming system, but tried to adjust it to match some of this stuff. So then we've got carbon monoxide. And you can see now that there is a mono showing that there's just one carbon. But like how you don't write a 1 for our subscripts when it's there, it's kind of leaving that blank implies that there's a 1 there. You don't need to write mono in front of carbon here. So you know the carbon monoxide, carbon dioxide names. You should know those formulas. So that's how I memorized that little trick with that. Now this next one, some people have a hard time knowing what this is. I mean, they're going to oftentimes call it water, right? But that's an informal chemical name, because water could be talking about, is that a liquid? Or is that a gas? Is it no longer water when it's a gas? People call it water vapor. So a better way of doing this is to talk about the chemical. And the real name for this is actually dihydrogen monoxide. So here you can see that we do need to give the mono and the di because there's 2 of these and there's just 1 of those. So if charge is no longer relevant, you need to say the number of atoms. If charge is relevant, use those. That's the main idea. So I'd say that this is covalent. Charges don't matter, or charges are not relevant. Which should make sense if you're thinking about ionic ions, covalent sharing of electrons. So the covalent things are actually attached to each other. They're sharing the things, so there's some partial charge. So we are oversimplifying things a little bit, going to one extreme and the other extreme in terms of like thinking about it. But we can say that charges are not relevant for covalent things for the big picture here. So those are your 3 main groups. But you can even see that within these 3 main groups, it's more like there's the covalent versus ionic. And then within ionic, there's a couple things. So now we're talking about, if we're talking about polyatomic atoms, or polyatomic ions, the word ions should tell you that this is not appropriate to be using with like a covalently bound thing. A polyatomic ion really should be with other ions. So it's going to be following these naming conventions, but then you use the polyatomic ion as opposed to like just the anion. So if you had something like, I don't know, Na2CO3, then this would be called sodium, because you don't need to do di or anything like that because the charges are known. And then this is just going to be carbonate. We've got sodium carbonate right there. So if you have a name, then you can also similarly get the formula just from the name. So if I gave you something like iron sulfate, then or iron, sorry, like 2 sulfate, then we can get something like that. So I've got iron, and then I believe this is SO3 2 minus, 2 plus. I believe this is going to be FeSO3, just kind of like that. And you can see that that's a +2 for the iron. There's only one of them. And a -2 for the sulfate. There's only one of them. And those should cancel out as is. Small error in here. Doesn't really affect it, but this should be SO4 2 minus. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.